Okay, so here is the second part of section 3.3, and we're going to look at what the factor theorem tells us here. We've just looked at the remainder theorem, and the remainder theorem said that the remainder in synthetic division, that value, is going to be the same value as if you evaluated the original function at the same value that you used in synthetic division. The factor theorem here says that if for some reason we do find out that your remainder is equal to 0, then the value that you plugged in, when we put it back with the variable x, it's actually a factor. So let's look at a couple of examples here then. First one here says, given the polynomial 2x to the third plus 7x squared minus 14x minus 40, determine if the following is a factor. If it is a factor, then find the remaining factors and zeros. So remember, the factor theorem and the remainder theorem kind of go together. This says we will find out, our question will be x minus 1, is this a factor? What that implies to us then is that if we were to take x minus 1, set it equal to 0, we'll find out that x is equal to 1. And from this, we'll use synthetic division, since our divisor was to the first power. And if the remainder is equal to 0, then 1 is what we call a 0, and x minus the 1 is a factor. So this is kind of what our train of thought needs to be for problems like this. This is actually working with the skill to help us as we move further into finding all of the factors and zeros. So in this first one here, we want to know, is x minus 1 a factor or not? And so like I said before, we'll set what needs to be used as a divisor to find the synthetic divisor. The synthetic divisor then is 1, and we are going to divide that into 2, 7, negative 14, and negative 40. Now, as I was writing this, I was watching the powers too to make sure everybody was present in the problem. You've got the cube, the squared, the first power, and the constant. If we go through our synthetic division, what we're hoping to find out is if the remainder happens to be 0, then you and I know we have a factor for sure, okay? Remember, in synthetic, we bring down our first term, multiply 1 times 2 to fill in the next column. Make sure you add those entries in the column. Now, 1 times 9 is 9. That adds up to be negative 5. 1 times negative 5 is negative 5. This last number here is what we call the remainder. This remainder, however, is not equal to 0. So what that implies to us then is that we can say that x minus 1 is not a factor because the remainder was not 0. That's the reason. Okay? Let's look at the next factor that they give us. They want to know the same question. Is this a factor? Is x plus 4 a factor? That's what they're asking us. So if we do the same thing as we did before, let's go in here and let's set x plus 4 equal to 0. This gives me x is negative 4. I will use that as my synthetic divisor in the exact same polynomial function that they gave us. And now we'll do the division. If the remainder is 0, then we have established that we do have a factor. Bringing down the 2, Negative 4 times 2 is negative 8. Add those together, you get negative 1. Negative 4 times negative 1 is positive 4. If you add those together, you do get negative 10. And negative 4 times negative 10 is positive 40. And check that out, our remainder is now 0. What that tells us then, right here, is that negative 4, the number I was using as a divisor, we call it a 0 now. We also found out that where negative 4 came from was x plus 4. And now that the variable's been written as in relation to our 0, x plus 4 is a factor. Now in this problem, they said if you find out that the given is a factor, we need to find the rest of them. And this is one of those handy tips that you need to know. You'll notice that we started off with a cubic equation. And now that we have a quotient, this quotient, remember you lose a power. We started with a cube, so now we have squared, then first power, then the constant. This is our quotient. The quotient's power is, the degree is 2, which means we have 2 possible zeros, which means we have 2 possible factors coming. And so what we'd like to do is we'd like to factor this. So if we take 2x squared minus x minus 10, because we're in search of zeros, we let this equal to 0. We'll go through our factorization. We know it's going to be 2x times x. Some of you may want to use the factor by grouping, that's fine. And then when we come out with our factorization here, I believe that this is going to have to be a plus 2, and this is going to have to be a minus 5. And so what I've just now found are my other 2 factors, okay? First, I know that x plus 4 is a factor because we proved that when you synthetically divide by it, you get 0. I took the quotient here, and I set it equal to 0, and I just found that 2x minus 5 is a factor, and so is x plus 2. So everything I boxed in red there are factors. If you want to find what the other 2 zeros are, then to find the other 2 zeros, all we have to do is set each one of our factors equal to 0. When you solve this, this becomes 5 over 2. And set x plus 2 equal to 0, and you'll find out that x is negative 2. So let me circle here in yellow for us. We just found out that negative 4 is a 0. And we also found from those extra 2 factors, x is 5 over 2, and x is equal to negative 2, and those are our zeros. For this last example, it's kind of playing it backwards for us. This one here says that someone has gone through and left us what they found out about zeros. And in this problem here, they found out that the zeros are 1/3, square root of 3, and negative square root of 3. And what you want to check is what degree did they specify for our polynomial. Our polynomial is degree 3. What this implies is that you should have 3 zeros. You should have 3 zeros. And sure enough, if you go back to see what they've told us, we know that our zeros, according to this problem, one of them is 1/3, another one is the square root of 3, and another one is the negative square root of 3. The reason I said this is kind of a backwards problem is they've told us what the zeros are. They didn't tell us what the polynomial looked like. So our job is to figure out what polynomial was this. And so if we take a look at where does 1/3 come from? 1/3 must have come from the statement x is equal to 1/3. The square root of 3 must have come from the statement x equals square root of 3. And negative square root of 3 must have come from this third statement. Each one of these statements then can actually go in here and now rewrite themselves to be like a factor. This first one, I can multiply both sides by 3. I get 3x is equal to 1. This means that 3x minus 1 equals to 0. Once it's equal to 0, we know we found a factor. So this is one of our factors. Likewise, we can look at the next one. X minus the square root of 3 is equal to 0. Therefore, that is also a factor. If we look at x is equal to negative square root of 3, if we add, whoops, I've written that incorrectly. Hold on. There we go. The negative should be on the outside of the root. Then this will end up being x plus the square root of 3 is equal to 0. And here's the third factor. So when I have all my factors, by the definition, factor means that they're to be multiplied together. And so depending upon what the instruction says on your homework, it may ask you to actually come in here and write the polynomial so that it's in factor form. And if they want you to write the polynomial in factor form, then we would write p of x is equal to 3x minus 1 times x minus the square root of 3 times x plus the square root of 3. If they want this polynomial to be multiplied out, then you will need to use the FOIL method to multiply this out. In my notes that are written out, I've done this. And so probably the best place to start when you multiply 3 different factors together is to look at, to see if any 2 of the factors have something that they can work with each other on. And if you look back here at the back, x minus the root of 3 and x plus the root of 3 are actually conjugates of each other. I think that's where I would start multiplying. All right, hope that helps. Please look at the written out notes for the final answer on this last example.